Today's topic is liquefaction of gases. So, liquefaction of gases. So, what is liquefaction? Liquefaction is the process of transformation of gaseous substances to liquid state. That means transformation of substances present in the gas state to liquid state. So, change in states, gaseous state to liquid state. This change is liquefaction. Liquefaction, that means transformation of the substance present in the gas state to liquid state. Liquid state. This is liquefaction. Just changes from gas state to liquid state. Simple. Right? So this liquefaction is very difficult actually. It is very difficult to transport from one state to the another state. Why? Because it is difficult? Because of its physical properties. Because of its physical properties. This transportation affects generally these factors: temperature, pressure, volume. Temperature, pressure and volume. These factors affects the transportation of state from one state to another state. Temperature, pressure and volume. Generally, Thomas Andrew discovered this experiment, liquefaction of gases. Liquefaction of gases. Thomas Andrew first discovered this liquefaction of gases. So, he discovered the experiment on CO2, carbon dioxide. Carbon dioxide. He discovered on experiment on CO2. So after this experiment, most real gases behaves like CO2. He concluded that most real gases behaves like CO2. First he conducted on only CO2 gas. Later he concluded that all real gases behaves like CO2. Right? So liquefaction means gas state to transformation from gas state to liquid state, right? So Thomas Andrew discovered experiment on CO2, right? So in CO2 generally he concluded and he decided CO2 at high temperature and pressure cannot be transformed from gas to liquid. CO2 gas at high temperature, at high pressure cannot change its state. That means cannot change its gaseous state from gaseous state to liquid state at high temperature and pressures. Andrew discovered that at high temperature and pressure, cannot change the state of substances. Substances means gases. We are talking about gases, right? Liquefaction means transformation of substance from gas state to liquid state, right? So Andrew discovered that at high temperature and pressure we cannot change the state of substances. That means we cannot change from gas state to liquid state, right? Critical constants plays an important role. Critical constants plays an important role, right? What is critical constants? Critical temperature, critical pressure, critical volume. These are critical constants. Critical constants, right? So critical constants means, so critical temperature first of all. So what is critical temperature? So at this temperature the gas appears in the form of liquid. At this temperature, the gas appears in the form of liquid. In the form of liquid, right? This is critical temperature. Andrew discovered an experiment on CO2, right? CO2. So, in CO2 case, the critical temperature is 30.9 degrees centigrades. 30.9 degree centigrades, right? This is the critical temperature for CO2, carbon dioxide. That means at this temperature, the gas appears in the form of liquid. That means liquefaction happened here. At this temperature, liquefaction process happened at this temperature. This is critical temperature, right? Next, critical pressure. So critical pressure is the pressure required to liquefy the gas. Pressure required to liquefy the gas. That means at this pressure, the gas is liquefied. At this pressure, the gas is liquefied. This is critical pressure. Whereas coming to the critical volume. Volume of 1 mole of gas at critical temperature is critical volume. Volume of 1 mole of gas at critical temperature. At critical temperature, volume of 1 mole of gas is critical volume. Critical volume. So, critical constants are 3: critical temperature, critical pressure, critical volume, right? So, critical temperature. At this temperature, the gas appears in the form of liquid. That means at this temperature, the gas changes its state from gas to liquid. At this temperature. And critical pressure. The pressure is required to liquefy the gas. Pressure is required to liquefy the gas. Whereas coming to the critical volume. Critical volume, right? So, the volume of 1 mole of gas at critical temperature. At critical temperature, volume of 1 mole of gas. This is critical volume. So, in the case of CO2, the critical temperature is 30. Right? Whereas coming to the critical pressure for CO2, 73 atmospheric pressure. 73 atmospheric pressure is for CO2. That means at this pressure, CO2 is liquefied. CO2 is liquefied. That means CO2 appears as liquid state. Liquid state. This is isotherms of carbon dioxide at various temperatures. At various temperatures, right? And this graph shows between pressure and volume at different temperatures. At different temperatures. So this is V1, V2, and this is critical volume, and V1, V2, here V3, and this is P1, P2, critical pressure, and P3, right? So at this graph shown CO2 gas at which pressure and which temperature changes its state from gaseous state to liquid state, gas to liquid, right? So here you have to observe at B point what happened here. At B point, generally some part of CO2 gas is liquid, appears as liquid, and some part of CO2 is still gas at B point, right? At B point, some part of CO2 converts into liquid and some part is still in gaseous state at B point. That means both liquid and gaseous forms exist in this B point. Both liquid state and gaseous state exist at B point, right? At C point, that means V2 volume, P2 pressure, right? At C, all the gas is condensed. All the gas is condensed. Condensed means condensed. All the gas is condensed. Condensed means vapor to liquid, right? Vapor to liquid, condensation, right? So all the gas is condensed here at C point. That means V2 volume and P2 pressure. That means here at C point, equilibrium between two states of matter. Equilibrium between two states of matter. That means both liquid state and gaseous state. Equilibrium between gaseous state and liquid state. Compression of gas results pressure P2 from P3 at C point. At B point, some part of gas CO2 is liquid, some part is still in gaseous state. At C point, all the gas that means CO2 is condensed. Condensed means vapor state to liquid state. All the gas is condensed. That means equilibrium between gaseous state to liquid state at C point. And at D and A. At D, A point and D point, what happened? A point and D point represents gaseous state and liquid state also. At A point and D point, both gas state and liquid state appears. And at C point, equilibrium between gaseous state and liquid state. Right? Here, PEC, critical pressure. At this pressure, here, critical volume, critical temperature, right? At this point, critical temperature point, the total gas CO2 is converted to liquid state. Converted to liquid state. Critical pressure 70. That means at critical temperature, at critical pressure, at critical volume, the gas CO2 is converted from gas state to liquid state. That means liquefaction process completely happened at critical temperature, critical pressure, critical volume. Right? This is all about graph. And Andrew Thomas concluded that behavior of all gases behaves like CO2. Behaves like CO2. He concluded that all real gases behaves like CO2 gas. CO2. He further concluded after many experiments, he concluded that all gases behaves like CO2. This similar behavior shown by gas at compression at constant temperature. Similar behavior Similar behavior shown by gas in compression at constant temperature. At constant temperature is called isothermal compression. Isothermal compression. Generally, all gases behaves like CO2. He concluded that. He decided that after many experiments. This similar behavior shown by all gases. Similar behavior shown by all gases in compression at constant temperature. At constant temperature is called isothermal compression. Isothermal compression. Similar behavior in compression at constant temperature. This is isothermal compression. Generally, higher critical temperatures higher intermolecular forces of attractions. Here forces means there is repulsions also there is attractions also there. Here I am telling attractions only. So at higher critical temperature, in case critical temperature is very high, then higher the intermolecular forces of attractions between molecules present in the gas. Right? Intermolecular forces of attractions also high at high critical temperatures. You have to remember this point very clearly. At higher critical temperature, intermolecular forces of attractions, and this means attractions between the molecules is also high in gaseous state. You have to remember this point. For liquefaction process, there is cooling is required and compression is also required. Any gas requires these two factors for liquefaction. These two factors required: cooling and compression. So what is compression? All of you know about cooling, right? At low temperature, obviously substance present in the gaseous state is cooled, right? But what is compression? Process of increasing pressure on molecules. Process of increasing pressure on molecules. This is compression. This is compression. Process of increasing pressure on molecules present in gaseous state. Gaseous state. So liquefaction process requires these two factors, cooling and compression. So compression means increasing pressure. Increasing pressure. Compression. These two factors definitely required for liquefaction. Liquefaction means transportation from gaseous state to liquid state. Gaseous state to liquid state. So why it is required? These two factors, why it is required for liquefaction? Compression, that means increasing pressure, right? So when we increase the pressure, what happened? When we increase the pressure, molecules are close to each other. Molecules close to each other, right? So leading to change in state. Change in state. So when we increase the pressure, that means when we apply compression to the gas, then molecules present in the gas are very close to each other. I am here. Intermolecular forces of attractions is very high. I have already told you about. That means forces of attractions more means molecules are close each other. So when molecules close to each other, then change in state. That means gaseous state to liquid state. That means liquefaction process happen. Liquefaction of process happen. Here I am explaining simply. So liquefaction means transportation from gas state to liquid state, right? So for this liquefaction we have required two factors, cooling and compression. So compression means increasing pressure, the process of increasing pressure on molecules, increasing pressure, right? So when we increase the pressure to the gaseous substances, so molecules are close each other. Intermolecular forces of attraction is very high. So molecules are close to each other, then leading to change in state. Change in state, that means gas state to liquid state. This is all about liquefaction of gases. Liquefaction of gases. Thank you for watching.